All right, so this is week 2, and we were working on lesson 3.2, which is about balancing blood alcohol and playing with that equation. So I'm going to bring that equation, a couple of versions of that equation that we dealt with up again to play with. I mentioned what the prep was about for today, and hopefully you did the prep last night. And so we're going to work together on lesson 3.3, but I got a couple things to go over before we can start on that. I made a new version of the Share Your Week, Share Your Work for week 2, and I'll go over that before the end of class 2. And we also have to talk about the prep for 3.4, which isn't too much different than the prep for 3.3 and what we're doing today. So, notebook, please. And let's get back to today's. Yes, I do want to save that. Oops. Oh, come on, there. There. And okay. And today, lesson 3.3. Okay, here we go. Can you see my written notes at the moment?
Yes.
Okay, cool. So the theme for today's lesson is lining up. Oops, that's the eraser. How did I do that? Okay. This is lesson 3.3, and before we get into some of the details for this lesson, let's look back from the last class, lesson 3.2. So the first problem we looked at is we had a young male, I think he was 120 pounds, and he had a few drinks, and we came up with this equation here for his BAC over time, and we calculated points for 1 hour after he finished those drinks, 3 hours later, and 5 hours later, and found that they lined up really nice. Some things that we noticed here is that from 1 hour to 3 hours, there was a drop by 0.03 for his BAC over those 2 hours. And that happened again here to get from this point to that point, the next point over here, from this point to that point, we dropped, so minus 0.03 over those 2 hours. Okay. And what we found was each hour, the BAC decreased or dropped 0.015. How did we get that 0.015? We took that 0.03, which was negative, and divided by the 2 hours. And so that's where we got that number right there. So this is the meaning of that number is there's a drop of 0.015% per hour. And let's highlight that a little bit. And whenever we do a division like that, when we look at how two things changed, sorry, I'm having a hard time tracking my pen on this screen, but hopefully I'll get used to it. So as we track this change here, right, the BAC changed over time. When we divide those two changes, that is referred to as a rate of change.
Is that where we did the 1, 3, 5 hour, 1 hour, 3 hour, 5 hour, or just the
that's correct. So yeah, so if you
Okay.
look at the bottom of my graph here, let's see, where's my pen? Here's 1 hour, 3 hours, and 5 hours later.
Okay, thank you.
Okay. Yeah. Now on the second page, we had a different scenario. We had a woman who wanted to drive 2 hours after having some drinks. And the question was, well, how many drinks could she have to be safe? So with the second graph I have here, where's my pen at? There it is. So this is for 2 hours later. And the question here was how many drinks she could have. So on the homework problem, the question only asked about 1 drink and 3 drinks, but for fun, I put a third one in here, 5 drinks, because I wanted to check, did it really line up this time? And it's hard to tell if things line up with only 2 points. 2 points always line up. So I needed a third point to check. So then I had the computer graph for me the calculation we made for what happens if this woman has 1 drink, what's her BAC 2 hours later? What happens if this person has 3 drinks, what's their BAC 2 hours later? And then just for fun in here, I threw in what happens if they had 5 drinks, what's their BAC 2 hours later? And you can see that these points definitely line up here. Now, the change from one point to another, what's going on here, is based on this fraction right here. So I need to play with that fraction a little bit more. Another thing to note why I'm picking on that number is if you look back at the rate of change I calculated in the first case, that is exactly the number that's being multiplied by t. So in some equations, if there's a number multiplied by a variable, that number may be the rate of change that we're looking for. So what I need to do next to analyze this graph a little bit more is to take a look at that 2.84 over 60.5. So new page, 2.84 divided by 60.85. And did I copy that right? That doesn't look right.
Isn't it 60.5?
60.5, thank you.
You're welcome.
I don't know where I got the 8.5. Oh, my basement phone is causing me grief. Oh, the fun of doing class from home, but I guess you guys know what that's like too. All right, so what I next want to do is I want to plug that into my calculator and see what I get.
But you got to change it to 05.
Oh, shit. I mean, shoot.
I mean,
Yes.
60.5.
60.5. All right, where's my eraser? Just erase that there. All right. So calculator time. And I think let's, for fun, use Desmos, scientific calculator, Desmos scientific, there we go. So I've got 2.84, and make sure I get this right, 60.5?
Yep.
Okay, good. Let's double check just to make sure Brenda agrees. Yes, okay, there we go. Pretty sure I wrote it right in my notes. Switch back. All right, so my calculator says it's 0.0469, blah, blah, blah. That's a lot of values there. So maybe I'll go, let's say 3 decimal places. So 3 decimal places, I guess I would call it 0.047. So this is, let's erase that. It's approximately, so wavy equal sign means I rounded, 0.047. Now, the meaning of this number comes from the graph. So if we look back at the graph here, we're calculating, let's see, highlighter, we're calculating the BAC. So that's the result of this calculation here in this equation. So that's the answer. We're plugging in the number of drinks. So the way that works for that number multiplied by the variable, it's, oops, wrong button. It's always gonna be the result you're trying to calculate, which is percent BAC, divided by what you're plugging in, which in this case is drinks. Another way to write that to kind of deal with the fraction, I could also write it as 0.047% BAC divided by 1 drink. So for every 1 drink I have, my BAC is going to go up by almost 0.05, or at least for this woman, right? If I rounded that roughly. So for each additional drink this woman has, her BAC will increase, because that's a positive number, by about, I'm just going to round that quite a bit up to 0.05. So if I rounded that to the nearest hundredth here, I would call that a 5. So that's the change that's going on in the graph. So back on the graph, to get from 3 to 4 drinks, right, that's 1 drink later, her BAC here is going to go up by about 0.05. And to get from 4 drinks to 5 drinks, right, that's 1 extra drink, her BAC again is going to go up by 0.05. So it's always the same. This is called the run horizontally here, and then this is called the rise that way. So I have a rise here of about 0.05 vertical, and I have a run here of about 1. And that's what we call rate of change. So over the next 3 lessons now, maybe 4, we're going to play with this idea of rate of change. All right, so another example of rate of change. It's also known as slope. Graphically, it's a rise divided by a run. And it's also what I mentioned earlier, it's the change in the vertical variable divided by the change in whatever your horizontal variable is, if we're looking at a graph. Okay, so here's another example. When I can find time, I like to bike. And in particular, I like to mountain bike. And some of the trails I ride on are kind of rough and they're up and down. So let's say if it's not too rough, not too up and down, that my average speed is 10 miles per hour. Now, whenever we use the word per, that means divide. So if I write that out in words, miles per hour, the word per literally means divide. So I could also say this is 10 miles divided by an hour. And instead of using that division symbol, I could write it as a fraction. Right? So alternatively, I could say this is 10 miles per hour. And usually when I write the word hour, I mean 1 hour, unless I put another number next to it, right? So 10 miles per hour is a fraction, 10 miles divided by 1 hour. And in the numerator here, I have my, that did not come out right, change in distance, change in distance. And in the denominator here, I have my change in time. So I want to make a graph of what it would look like for me to look at how much distance I cover over time if I'm out mountain biking. And this is on average. So if it's hillier, it's going to be a little bit different. Uphill is different from downhill, stuff like that. let's see, can I pull this off on this? I need to draw a straight line. Hey, it worked. Another straight line. All right, that was funny. Let's try that again. Okay, wish me luck. Straight line. There we go. Okay. So I'm going to try and graph here the number of hours versus the number of miles that I go. And this is title Gary Mountain Bikes. And let's go for 1, 2, 3 hours. And if I mountain bike for 3 hours straight, I'm probably going to be almost dead after. But let's just make believe I can do that today. And then, for example, I just said, like on average, I can do about 10 miles per hour on a good day. So after 1 hour, if I say 10 miles is right there, then I should have a point on my graph that has 1 hour goes with 10 miles. And then what about 2 hours later? What do you think how far have I gone if I went 2 hours at 10 miles per hour?
20.
20, right? So, okay, so that's 10, 20 is going to be around here, say. And so then I should have a point somewhere about there. And 3 hours later, that should be another 10 miles, so 30 miles. So I should have a point somewhere in this vicinity. And if I spend no time biking, I got no distance. So I got a point over here at 0, 0, if I wrote it as a point. And so let's pick a new color. The cool thing about this, if my distance stays at 10 miles per, my speed stays at 10 miles per hour, then I should get this nice straight line through those points. So if I say hours is the variable x and miles is the variable y here, in the previous page, I said my slope was 10. And I'm just keeping track of how much I biked like today, right? And at first I haven't biked anywhere. Then all of a sudden I get on my bike and I start pedaling. So my starting distance is 0. So slope is 10, starting at 0 miles because I haven't gone anywhere yet. So that's this right here. And so the equation that y equals mx plus b I was talking about, I got 10 for m. Oh, what happened to my x there? Try that again. Oh, I know what's happening. There we go. Plus 0. At first glance, that's my equation, but what happens when you add 0? Well, nothing happens. So I could simplify this. Sometimes these simplify, sometimes they don't. Simplify and say it's just y equals 10x. So this right here is the equation for the graph that I drew here, just based on, hey, I bike on average about 10 miles per hour. So our goal here is to get used to, in a situation, which number given is the rate of change, the slope, and which number is the starting point, the initial value. And we're going to try and distinguish between those things. So let's break out of this page and take a look at the lesson together. Back here, and where's Zoom? Hi, Zoom, there you are.